Hello, my name is Mario Castro. We'll be doing a video, which for the record I have never done, but we'll be doing it. And what we'll be talking about today is the concept of the capillary action of water. The reason that we're going to be talking about that today, not only is it a simple concept, but it's a fundamental concept based on the properties of water, and becomes very crucial when it comes time to measure items and in order to be able to get an accurate description of what we're measuring. So it is something that I remember being taught in middle school, but even then there's people now that through high school, college, still don't know what it is. So I'll be kind of going over it. So first question is, what is it? Essentially, it is the adhesion of water on an object, usually like a bottle. A lot of times in lab, it's test tubes. So the next question would be, why does it happen? And it comes down to the hydrogen bonding between, I should just say hydrogen bonds. What ends up causing is the interactions of the hydrogen molecules with the oxygen end up creating this hydrogen bonding that when water is poured into a cup or a test tube, it ends up still wanting this to attract to itself, but at the same time there's some that doesn't quite make it all the way down to the rest of it. So that action is called capillary action of water. Through this hydrogen bonding, a lot of properties of water come along with it. A short example is water striders, or the bugs that walk on water. It allows them to be able to walk on it and not sink, which is pretty impressive. But it's also the reason why, once again, the water molecules stick to each other, and it causes this effect. So right here in front of me, I have this glass bottle, essentially representing what a test tube would look like. Not that we can't see it in this plastic bottle, but we'll be using this one to demonstrate. So I'll just go ahead and pour this in here. So assuming this is our test tube, what we end up doing is seeing a bunch of markings. Now this one is not a test tube, which is why it has no markings. But in order to be able to read our measurement properly, because of this concept, we do end up needing to lower ourselves to eye level, which, if you're able to look closely, the edges of the water are kind of in what people may call a U shape, or eventually leading to it causes a meniscus. The importance of this is that because it causes a meniscus, it alters what we're actually reading. And a lot of people have said this, read the bottom of this, because read the bottom. So this is the reason why I wanted to go over it, because if you're able to see, the water is a little bit elevated on the sides, essentially giving a false reading if we were to go ahead and take a test tube and read it just right off the top. So yeah, that's the concept, capillary action of water.